Please take a moment, read over example 13.4 and answer letters A through D, and then come back and check your answers. So I paused for a moment and put in some of the answers. The observational unit should be hopefully have been pretty clear. It's each trick-or-treater, age 3 to 14. You could say in Connecticut, you could give more detail, but that would be adequate detail. The variable type is whether they chose a toy or candy. It's categorical and it's binary. Okay, they only had two choices. They're going to choose one of the two. The sample are 283 trick-or-treaters. You could have said 283 trick-or-treaters in Connecticut. Parameter of interest. Now, this is where it gets a little more challenging. P is the proportion of all such trick-or-treaters who chose. It's like, well, which one do I do, toy or candy? Honestly, it doesn't matter. You need to choose one to test and then be consistent with the number all the way through. I chose to test candy. Because if you find a lot of, if you find a preference for, are we looking for specifically for a preference? And that's where I guess we should step back for just a moment. So before I continue with that, why did I choose candy? I chose candy because, well, I like candy more than those little glow-in-the-dark bugs, personally. Now, the hypotheses. We have to do the null and the alternate. The null, nothing special is happening. In other words, they just choose randomly between one of the two plates, is 0.5. P equals 0.5. The alternate, you also have to put P and 0.5, but we don't know what sign to use. Looking carefully, and this is where it can be a little challenging. If you look at the second line, it says, as tempted by toys as by candy. They don't say more tempted. They say as tempted. So they're looking for a difference. They're not sure if it's, they're not thinking it's, they're trying to see if it's not split 50-50. Are they as tempted by a toy as by candy? So we're going to look at not equal. All right. So there's more preference for the candy. Maybe there's more preference for the toy. I chose, like I said, to test candy. And so I'm going to want to make sure I use the counts related specifically to candy. Okay. And you're like, well, how would I get the counts? Here's where I was told. Of the 283 kids in the study, 148 chose candy and 135 chose a toy. Now, given that I'm testing candy, find the relevant statistic. What symbol am I using? Well, I'm using p hat because remember that is the statistic related to a categorical variable. This is where I once again I have to think about, okay, I'm going to be testing candy. So I'm going to look at the 148. If you said, well, what if I want to test toy? Then you would just put 135 instead in there. And I got 0.523. Now we're going to carry out a one proportion z-test to report a normal approximation-based p-value. But it does say here, it's giving you a hint, be sure to first verify that the normal approximation is valid here. So please take a moment and check to see if the normal approximation is valid. Write down the steps that you did, and then we'll come back. And I will tell you, just giving you a hint, the normal approximation is valid to use here, but please do the writing down of the steps. So in this case, as p is 0.5, we know that n times p and n times 1 minus p will end up with the same value because we have 0.5 there. It ends up being 141.5, which is definitely more than 10. We also know that, well, Connecticut's a fairly decently is a fairly populated state. There are definitely more than, let's say, 2,830 trick-or-treaters in the state of Connecticut. Therefore, we've met the three conditions, the n times p, n times 1 minus p, each being at least 10, and that the population is at least 10 to 20 times the sample size, so the normal approximation is valid. So what do we now need to do? Well, we need to find that z-score. Remember, that's going to be the p hat minus p over that standard deviation. Personally, what I would do is I would calculate the standard deviation separately. And remember, that's p times 1 minus p all over n, and we take the square root. So please take a moment and calculate your way to get your z value and come back and check your answer. And there we go. Now, when we do not equal to, it's a little bit different. So we know we're going to have normal approximation. And here we're saying the z is 0.77. So we're looking for anything 0.77 in this tail. But as the null hypothesis, as the alternate hypothesis is not equal to, we're going to have to look at the value in both tails because we're looking, is it different from? Alrighty. So the p-value is actually equal to the area under both tails. So it's going to be the area here, if you look it up in the table, is 0.2206. So the p-value is 2 times that, which gives me 0.4412. Now, if you think back to that table that we have, that's a large p-value. So we do not have much evidence against that null. We don't have evidence for the alternate hypothesis. Stated conclusion in context. So this is the first time we're going to be stating one where we don't have evidence against the null. So I'm going to say, based on a largish p-value, we have no evidence of what? That kids, or you could say trick-or-treaters, kids have a preference for either candy or a toy. And there we go. So in the end, we ended up not having evidence against our null. So should this be the end of it? No, it would probably lead to a different study, looking at it more in depth, maybe using different candy, like a better candy, and maybe using a better toy. Maybe a different part of the, probably still do it in Connecticut again, because we'd be interested in seeing if there was ways we could make that change. Maybe offer fruit and a toy. Ugh, no, because we're interested in candy. Yeah. But anyways, it would lead to further study. It's not like this is the very end of where this would all lead to.